So our next speaker is Patrick Foley. He is a staff deep learning engineer at Intel, but he is one of the main proponents behind a drive towards federated learning in Intel. And we've been talking to Patrick and his colleagues now for more than a year on how Flower and Intel can work together. And so I was delighted when they invited us to join this OpenFL consortium involving a number of other industry partners towards building interoperability within federated learning platforms. And so it's wonderful to see Patrick joining us from the West Coast to describe this effort and why it's so important for the future directions of federated learning in general. So thank you, Patrick, for joining us today. We're really delighted to hear what you have to say.
Thank you very much, Nick, for the warm introduction. And it's been a pleasure working with the Flower team over the last couple of years, both on interoperability efforts as well as some of the shared priorities that we have with the ML Commons and MedPerf work. So as you said, I'm here today to talk a little bit about some of the efforts that we're doing together around federated learning standards, both in terms of what is driving the need for them, and in terms of the work that the OpenFL team has been doing, as well as the Flower team, around actually making concrete steps towards building both standards for ensuring long-term interoperability of federated framework algorithm implementations, as well as shared components that enable users to conform to a standard and actually build higher level frameworks on top of. So just as a bit of a bio, so my name is Patrick Foley. I'm the lead architect of the Open Federated Learning project at Intel, or OpenFL. I've been involved in the AI, security, and health and life sciences space for the last decade. My career has spanned working on federated analytics for healthcare applications and a project at Intel called the Collaborative Cancer Cloud. I pivoted into working on deep learning frameworks such as Onyx Runtime and building Intel Accelerator support into these after that point. And then most recently, I've been involved in Intel's federated learning efforts around OpenFL and the Federated Tumor Segmentation Initiative, which brought together over 70 research institutions across 6 different continents to actually do a true healthcare federation and improve brain tumor segmentation models for the purpose of delineating where tumors are, glioblastomas in people's brains. So as far as an overview for the presentation today, I'll start by just giving a short intro into OpenFL and the work that we're doing there. From there, go into some concrete ways that Flower and OpenFL have been working together over the last couple of years. Then diving into what is really driving a need for federated learning standards, because this is such it's been a rising field of AI in the last couple of years, and really we're at a point where there's a maturity, I think, that's going to be that we'll have to transition into as a field, and then what the benefits of standardization and shared components really bring to the wider FL community, and then finally a call to action in terms of how the Flower community and the wider FL research community can contribute to the long-term development of standards in this field. So just a short intro into OpenFL. So as Nick mentioned, there's been a strong collaboration between our teams, and there is the Flower Labs is a driver of the technical steering committee for OpenFL. And so what OpenFL is the outcome of the work of the FETS initiative largely, and real world experience that was gained by actually developing a privacy and security first federated learning framework for healthcare applications. And so in 2017, Intel Labs, which is the research component, research and labs component of Intel, my group, which is formerly in the Internet of Things group, at Intel and the University of Pennsylvania started collaborating on a new way of actually applying federated learning, which had just been coined as a term the year prior by Google with their Fed average paper, and trying to apply these type of ideas to the healthcare domain. And so what we found at that point was that by applying federated learning to healthcare, we were able to achieve 99% of the accuracy versus a centralized model. And this was really a great proof point for deploying a real world healthcare federation. So the OpenFL work really stemmed out of the security and privacy research group at Intel Labs, which has been focused largely on how to, and they've done a lot of deep thinking, and Micah Scheller actually presented in the Flower Summit 2022 around some of the priorities that came into OpenFL, such as how to limit the possibility of remote code execution, and really taking a considered look at how to actually maintain user privacy, both from a software context and the algorithms that get applied to the data and the aggregation algorithms that combine it together, but also thinking through hardware-based approaches for verifying the work that is done by others across the federation. And so OpenFL is designed largely around, so we use very similar components actually to Flower, in that there's a gRPC client, and a server that runs on the aggregator. And instead of sending the entirety of a deep learning model across the network, model weights are the only information that gets sent between both the collaborator and the aggregator, or the client and the server. And so this has a number of benefits because it as I mentioned, limits the potential of remote code execution, but it allows for, it has the secondary benefit of allowing OpenFL to be agnostic to the exact type of deep learning model that's supported underneath. And so we transform the underlying weights of either PyTorch, TensorFlow, MXNet models into NumPy arrays. These get serialized into a protobuf and sent across the network to an aggregator, where an aggregation scheme can be applied that combines those weights together. So OpenFL, is part of its name, is open source, and so we've recently moved from an Intel driven project into what we want to be a community driven project. And so now, instead of an Intel domain here under GitHub, you'll see secure federated AI. And OpenFL is lucky enough to be driven by Intel, as well as Flower Labs is a driver of the technical steering committee, as well as our original collaborator at the University of Pennsylvania, Leidos, and others are also part of this community as well in terms of driving it forward. So getting just a little bit deeper into the OpenFL architecture. So I mentioned that there's a gRPC client as well as a gRPC server. TLS is, because security and privacy are essential to federated learning and the OpenFL design, we strongly recommend the use of TLS certificates and provide mechanisms for people to get up and running with that quickly, even for small federations. But OpenFL has a notion of a plan, a federated learning plan that everyone agrees to prior to participation in an experiment. And so this really denotes both the model that's going to be used, as well as any of the hyperparameters for that model. It includes some of the network topology information and anything else that remote institutions would need to verify before this untrusted code could be run on their infrastructure. So in terms of the information that gets distributed across the network, there's an out-of-band copy of both this FL plan as well as all of the model code and data loader code that's going to run on remote infrastructure. So from there, getting into some of the collaboration between Flower and OpenFL over the last couple of years. So this really started as there was a proof of concept that Micah Scheller on Intel Labs and Daniel Butil took together for implementing a federated learning approach to ML cubes, which is a prepackaged mechanism that's completely Dockerized for running training and validation tasks for machine learning workloads. And there was an effort to see if this could be run in a federated setting, because the benefits of having a containerized workload that define both the model implementation as well as the training and validation tasks are really, there's some nice properties to those, and so this was a great initial effort for demonstrating how whether it's OpenFL or Flower or a different federated learning framework, these could be used for having well-designed workloads that are actually reviewable ahead of time. So Flower is also a member of the technical steering committee for the OpenFL project, and the OpenFL team as a whole is very serious about making this community driven. So we don't want a single corporation or research institution to have total control of the future of the project. We really want this to be a collaborative effort that we embark on together to really make the federated learning research community succeed. So we've spent quite a bit of time together, individually as well as collectively, talking about or going through our individual designs of different federated learning components. And the way that federated learning frameworks have operated up until today is that everyone, for the most part, is reinventing their own ways of doing federated learning framework implementations, and largely what this consists of is having a distributed application that chooses first either the RPC mechanism that's going to be used, whether there's a client server or pub sub that's used for communication between clients and servers, and then having mechanisms for getting and setting weights for individual models or model types, and then having serialization, deserialization mechanisms for sending all the information across the network. And then a lot of the other work is defining convenient interfaces for people to port their existing deep learning framework implementations into. And beyond that, but there's a lot of other really interesting problems in the federated learning space, because as opposed to distributed training, there isn't a single operator that is deploying the entirety of the workload. And so the concept of trust is really a tricky problem to solve. And there's great ways that Flower has implemented secure aggregation algorithms like SecAg and SecAg Plus. But there's also a need for, there's a complementary need for hardware-based approaches that can augment this type of work. And so I think between our two teams, there's a recognition that there's a lot of things that we're doing individually that could benefit from standardization. And then there's also a lot of harder problems in the FL space that we would like to both solve together, as well as I think individually as well in the areas of our joint expertise. And so getting into the driver of federated learning standards. So as I mentioned, there's been a lot of work up until this point of reinventing the wheel. So that model serialization, RPCs, compression is another big one, because in addition to the data privacy driver of federated learning, the size of data is another reason for why people don't send all of their data to a central place. And so having so compression is really a critical piece of federated learning frameworks as well. And so this is an area where people are typically required to roll their own when they're developing these frameworks from scratch. aggregation methods, there's of course a vast number of aggregation methods that are supported and or that are recognized in the FL community as being effective. And I mean, between Fed average, Fed prox, Fed curve, Fed BN, et cetera, there's many that deal with different types of problems very well. But identity and certificate provisioning, this is another point that goes back to how the trust aspect and security aspect of federated learning. And I know both Flower as well as OpenFL have their own TLS implementations and certificate provisioning that needs to be set up ahead of time. And so this is not something that's necessarily core to federated learning, but it is a peripheral piece that's really necessary to be able to have some element of trust in terms of who you're communicating with. So in terms of the life cycle of federated learning frameworks, a lot of the choices, and this I'm speaking mostly from the perspective of the OpenFL team, a lot of the design choices that we made early on can be biased by the early set of users and customers that we're working with. And because OpenFL largely came out of the healthcare space, there's the potential that we're more biased towards those types of applications. And so in the definition of frameworks, I mean, good framework authors try to do their best to come up with very generalized implementations, but there's always a possibility and over time that as the community grows, there's a realization that there's great use cases out there that people want to be able to implement in these frameworks, but it's not easy to necessarily adapt the early work to the new needs and future directions of the projects. And so for all of these frameworks that are working in small communities of designers today, there is a risk that of bias towards a particular implementation that actually hurts the long-term interoperability of the framework over the long term. And then the last point is that the federated framework space is pretty fragmented today. And because federated learning was only coined as a term back in 2016, we're 7 years after that, there's a proliferation of federated learning frameworks that are still there, and there's still, I think, more. There's 2 or 3 more every year, depending on where you look. And so, just as a sample of this, so of course there's Flower, which you are all very familiar with, OpenFL, but also many others that have been around for a long time, including FedML, TensorFlow Federated, FedBiomed, PySift, which is of course incredibly popular, and NVFlare, I think, has started up in the last year and open sourced a lot of their work. So there's, and this is only a small subset of all of these frameworks that exist. And so the question that we had started asking on the OpenFL team is, with all of these federated learning frameworks that are being created, we kind of expect that there will be some consolidation of different implementations in the near future. And so this is very similar to the evolution of deep learning frameworks from the early days. So I mean, and now that's been reduced to probably 2 or 3 big deep learning frameworks that are out there. And so what we expect is that that consolidation effort, there's a lot of benefits that each of these frameworks have in terms of their strengths, but then because everyone is doing a lot of their own implementations from scratch, there's some weaknesses that others have too, just because of how teams are staffed and the domain that the frameworks originated out of. And so this really brings me to some of the platform components that we all build from scratch in many times, and different frameworks implement these different categories to certain extents. But there's typically the weight getting and setting. There's an interface for working with private data. Many federated learning frameworks have their own interfaces, both lower level interfaces for working with the core deep learning frameworks, as well as higher level interfaces that try to abstract away as much of the topological complexity as they can. But the point is that we're really all doing a lot of this work from scratch, and there's clearly some potential for building some of these components together, or bringing in other experts from the outside community that have domain expertise in these areas to build a true foundation for reliable implementations that people have confidence that are going to exist over the long term. And so, getting into some of the benefits of where this standardization work can really help. So some of the conversations that the OpenFL and Flower teams have been having, there's a variety of categories that I've touched on already, and I should mention that a lot of the slides that I'm presenting come out of work from these conversations. So this is certainly not an Intel only driven effort. This is largely code-driven by the Flower team at this point. And in terms of interoperability, in terms of, that we've identified as some potential, by having models that are serialized in common ways, or having a language that can express how models get serialized and deserialized, and as well as having common remote procedure calls. So because OpenFL and Flower are both built on gRPC today, or at least have support for gRPC, there are specific RPC calls that both frameworks implement that allow for the necessary information from the server to be communicated back to the client, whether that's the aggregate model or information about which tasks should be run on the collaborator, et cetera. And so by having some standards that are defined around model serialization and some of the and longer term towards some of these RPCs, and having common ones, we would have the ability to actually run hybrid federations, which is really compelling for a number of reasons. The first of which is that on the aggregator versus collaborator side, or server versus client, there's different strengths that different frameworks have. Flower is very strong in terms of the device support that they allow, and I think that the team's done a really great job in terms of bringing in the widest community that they can. So I was looking on the GitHub repo in the last couple of weeks, and I didn't realize that there was iOS support now in Flower, which is fantastic to see. So because Flower has support for iOS, Android devices, there's I think the potential of actually pulling in these wider federated learning experiments that run on mobile devices. But one of the strengths that Intel has is security and privacy, and specifically around hardware security and privacy. So with the use of trusted execution environments, there's the ability to verify through a remote service the integrity of the code that launches on a remote machine, and that's called remote attestation. So Intel has a processor technology called Software Guard Extensions, SGX, and that actually originally came from the Security and Privacy Research Lab that designed OpenFL. But this allows for scenarios where there's a truly trusted aggregator, where Flower clients could be used with a trusted aggregator who is not going to extract the local model updates from an individual client and reveal their or try to recreate their data distribution in some way, or find out other information about the local data that could exist on that device. So I think this in the future could open up some really interesting possibilities that we would certainly like to pursue. In terms of benefits to researchers, and if we start thinking through the long-term other areas that would be components for standardization, one of the things that we've talked about is aggregation function interfaces, and I think Flower's done a great job of pulling in new researchers into the wider Flower community, and on the OpenFL side, we have a number of teams that have been collaborating or have been submitting their own algorithmic implementations back to OpenFL, and so we would love to have this scenario in the future where people can write to a standard interface, and then this becomes portable either from OpenFL to Flower or from Flower to OpenFL. And the benefits of having these standards that are in place for allowing this portability of algorithm implementations are that there are going to be first more eyes on individual implementations of these algorithms to try to reveal any bugs, I think, early on. And this also has benefits to the frameworks themselves, because if there's different behavior that's observed between Flower and OpenFL, that allows for quicker bug fixes to be brought in on either side. And then one of the other benefits to researchers, especially over the long term, are that by having these standards that are very well defined and in place early on, there's something that we've seen at least on the OpenFL side where people will write algorithms for an earlier version of OpenFL prior to, say, the 1.0 release. And over a 6-month to 12-month period, someone will try to take that code and run it locally, and then something will break. And part of this could be due to changes in interfaces or changes in the underlying framework that is supported. And by having these standards that are in place, and more importantly, the commitment to standards from a framework level, we're going to be able to limit that unintended deprecation over the long term. And so having standards that are well defined, we can point people towards an earlier version of the framework, for example, that has the dependencies pretty well defined and guarantee that the code is going to be able to run the same as the day that it was written. In terms of some of the framework benefits for both Flower, OpenFL, and anyone else who decides to join this consortium. So I talked earlier on about the bias in implementation, and because we're working largely or in some ways in silos today in terms of the implementation of things. And I think different frameworks do better jobs of pulling in the community driven components than others, and I think Flower does a great job here. By having more viewpoints in the room and more perspectives, there's going to be more consideration of different use cases earlier on, and this has the potential of avoiding a lot of the redesigns that we've seen, at least on the OpenFL side, when new users come in and they have a great idea for research that they want to do. And a perfect example of this comes from a conversation that Daniel, Nick, and I were having a few weeks ago. And because OpenFL doesn't support Android devices today, we were talking about serialization standards and the types that should be supported for transferring across the network. And the general consensus was a byte representation. But Daniel brought up in the case of Android devices, because there's cases where big endian will be the representation instead of little endian, bytes would not be necessarily. There have been users who have been asking for a float as a type that should be transferred across the network. And so having that type of discussion in an open way, I think is really great in terms of figuring out what the right standard is going to be for the long term, because those were not considerations that the OpenFL team would have had in the design of that serialization type of method. The second piece around framework benefits is that it improves the quality of a lot of the shared components, because the reality is that a lot of the teams that are working on implementing these frameworks, some of them can be fairly small and have expertise in a certain number of areas, but not necessarily all of the areas that are really required for federated learning frameworks to function in a variety of environments. And so by having more developers from multiple teams that are collaborating to a single design, there's going to be better expertise coming in that's most familiar with the component that's being developed, and more eyes on the review of these components as well. And then the last piece around framework benefits, and I should say that all of this is a subset of what we see the benefits as, but by having these shared components that are in place, so standards is really the first level, but then shared components being the second, it really creates a foundation for higher level interfaces and the next generation of framework implementations. And the point that, at least for the OpenFL team, where we'd love to get to is that people can write for a single interface that they really like, and that may be for Flower, that could be for OpenFL, that could be for Fate or somewhere else, and it's going to run on whatever infrastructure people have at their disposal, and it's going to be supported over the long term. And that's really one of the key pieces that we want to really stress, because there's some risk in because the community is somewhat fragmented today. There is always the potential that 5 to 10 years from now, the work that researchers are doing and is at risk of not becoming reproducible. And so by having these common components that are well supported by a wide open source community, it reduces at least the risk of that deprecation happening. So in terms of some of the priority components that we've discussed for standardization, so the serialization and RPC calls, I think, is likely going to be where we'll start in terms of some of the definitions that we'll put forth. But there's a number of others that are on this list as well, and I should say this is nowhere near exhaustive. But the storage interfaces and backends. So on the OpenFL side, we use a pandas data frame is our storage backend in many cases, but there's longer term services. I mean, we've talked about having a Redis backend for where tensors or layers of certain models can be stored over the long term and can be recalled by a permissioned participant for actually aggregating those those layer weights. And aggregation algorithms is, of course, the portability of having these from one framework to another has numerous benefits. Compression methods, this is, of course, not core to federated learning, but there's a number of great lossy and lossless compression methods that are out there. And having people with expertise in that area contributing to these standards that we'll define, I think, is going to be critical in terms of being able to scale to incredibly large federations over the long term. And then model weight extraction and setting operations. These are fairly standard between PyTorch, TensorFlow, et cetera, but we all do things in just a little bit different way. And so by having these standardized across our frameworks, this would allow for, I talked about hybrid federations a little bit earlier, but having a model trained initially within a Flower federation that could be used as input into a OpenFL federation long after the fact. And the same point goes for the storage interfaces and backends. Having an OpenFL client that's able to use information stored from another Flower client, I think is really compelling and something that we would like to see. And then something that I haven't touched too much upon is federation governance, which is really how many federations can work with each other and have data that gets registered with a central entity for the purpose of discovery from others in a federation, and being able to support many federations one after the other with confidence that you have the integrity of the data set has been verified ahead of time, as well as the participants are who they say they are, and have this backed by the use of trusted execution environments where at a hardware level, there is a guarantee that the code that was originally agreed to ahead of time is actually what's running. So I think that there's a number of areas that are exciting for some standardization and common components to be built upon those. And so the last slide here is really just a call to action. So there is a repository that we've created under the secure federated AI GitHub repository, GitHub organization called Federated Standards. This is where we'll start by defining some of the standards first for probably serialization, deserialization, and then building some common components over the longer term as well. So one of the things that the Flower team and OpenFL have talked about is putting a blog post together that really distills the goals of a lot of this work. And we'll provide a lot more detail beyond the presentation that I've given today. And then the last point here is that we want to get the wider community involved in the standardization effort. And so OpenFL and Flower are just two of the federated learning frameworks that are out there. There are, of course, many others, and we want to encourage participation in the standards definition. But for the Flower community who is with us today, we would love for you to get involved with this effort as well. So as we're going through the process of designing what these components are going to look like and the standards are going to be, we're going to have a proposal process that we're going to put forth, and we would welcome comments from the community on this and just try to understand how it maps to the use cases and research that you're individually doing. And then the implementation of some of these common components, we want to draw on the wealth of the great community that's been built around Flower as well as OpenFL, and get as many eyes on the implementation, or get as many hands on the implementation of these things as we can, for the purpose of both creating as much of a common base as we can, and as well as the purpose of as many eyes for the purpose of review. So with that, I think I'm just about out of time. So I would welcome any questions, and thank you for having me today.
Thank you very much. I mean, this is a super critical effort if federated learning is going to start to take off. So I'm really happy that you gave this talk as great initiatives. Questions from the audience. We've got one from Daniel. And while Daniel's asking his, feel free to think of one more.
Not so much a question, more a comment of, first of all, thank you for the great talk, and also a big thank you for inviting me to the technical steering committee. And it's been a great pleasure and honor to work with you and Micah Schaller and Prashant Shah and many other great people on this effort. And I can't overemphasize how important such an effort is, because I think that we, as the entire federated learning community, we're still together in this effort to convince a lot of to convince the world basically to trust this technology and to see the chances in deploying it more widely. And I think building out standards, building out shared components with that are heavily tested with strong test suits based on standards, I think this is a vital component to gaining the trust of organizations to deploy this in production and to deploy this on critical data.
Yeah, thank you, Daniel. And the feeling is mutual. It's been fantastic working with you, Tanner, Nick, and others on the Flower team, and we're really excited to build some of these standards and components together.
We'll take 2 more questions. So we have Sachin here from Qualcomm.
Yeah. Hey, thanks. Great presentation. I'm curious to get your view, just generically speaking, on pros and cons of standardization. And maybe this is for the Flower team as well, because just historically, if you look, there's great things like, I think some of the video codecs, H.264, with, that's a little more technical. This is obviously more of a framework thing. So I'm curious, of course, there's pros and cons. What do you see? I see a lot of the pros. What do you think are the cons that we have to work together as we try to standardize?
That's a great question. And
I'm hoping for more pros, of course, but I just want to be eyes wide open.
Yeah, well, let me start maybe with the cons first, because I think that because federated learning is so new, is a field, there is still some risk of bias, even as we're developing these standards. So by having OpenFL and Flower as part of this initial team that's building these standards, the hope is that we reduce that bias, but there's still chance that we're going to be biased just because we're only 2 out of the 10 or 15 or more frameworks that are out there. And I also think that there's going to be evolution of the federated learning field over the next 10 years in terms of combining it with different forms of machine learning, confidentiality, and privacy methods. So I think that there's certainly that, and there's also, I think, risk of having a standard that gets created and then I mean, potential for competing standards down the road, of course, as well. This is where I think part of the work that we're doing around standards is strategic, because there is not a well-defined standard for federated learning and the different components that are needed today. And so we're trying to create a critical mass of really what we think is the right community direction for a lot of the components that we're working on, and that we can create a platform for others to build off of. So it's really intended to be as open as we can possibly make it, and just build a common base, so that, because we expect that there's both going to be consolidation as well as a proliferation of frameworks, in the same way that we've seen lower level frameworks kind of consolidate for deep learning, but higher level frameworks really expand. And so this is a lot of the, I think, potential for it, but it's there's also I think risk as well, because at least at the beginning, the implementation and design might not be. There's still it could pivot towards. We could eventually need to expand the standard and version too quickly. But I would be curious to see what the Flower team thinks here.
Well, I think we just have time for one more question, though. So I'm going to go to Stefanos, who's from Brave.
Hi, thanks, Patrick, for the great talk, and a lot of information there. So I'm coming from the web standards kind of community. So I would like to ask if you have a specific interpretation of the standards from the prism of the web and deploying it in a more, let's say, wide area network, where potentially the framework is not necessarily tied to the operating system, but it's more open in the sense that it can run over a browser, over a WebAssembly, or whatever this might be. Thanks.
Yeah, great question. I don't have necessarily a strong response for that. I think that Flower has worked a lot more substantially with web standards there, but and this is where I think the perspective of the Flower team especially, and we would welcome, I think, the Brave team as well, in terms of the implementation and design of these standards, to be considerate that we're not just building something that is intended for Python frameworks to operate, but is that we'll be able to communicate over standard web interfaces as well.
Well, with that, I better start to wrap it up. But I guess I would like to say that, the standards really invite a lot of input from folks to get them right. And so the intention here was, this talk was to make public what we've been working with Intel and OpenFL for a while. And then it's meant to be a bit of a launching pad to write a white paper, a blog, and so on. And so anyone who's excited and interested in these things, they should just reach out to us, and we can engage as a collective rather than just two entities thinking what we think is best, and we should think what everyone thinks is best. But with that, again, thank you, Patrick, for the great talk. It was amazing, very important topic. So thank you for finding the time. Let's give you a round of applause one more time. And over in the UK, we're going to go to break for around 15 minutes, then come back for the final session. So thank you, everyone.